So today what we're going to do is we're going to look at 7E, which is the last section in chapter 7 that we're going to work on. We're going to be talking about the future value of a loan or investment. So in other words, how much would my investment be worth in 20 years or something? And this is going to use something that you're very familiar with. You're going to be using the compound interest formula. Now remember, when we started this chapter, what we were doing was we were looking at compound interest where we just wanted the amount, the value of the loan for each specific period. So for that, we use the sequence, right? The recursion. But for this time, what I'm doing is I'm looking for a value in the future. And I could get it by still... Okay. So the compound interest formula will give us that future value of a loan. So we're not looking for individual compounding periods. That's when we use the recursive formula, right? This time we're looking for a value in the future. And so you remember, we have A equals P times 1 plus I raised to the n. So it's not the effective interest rate. We're talking about the compounding interest. So make sure you get the right one. All right? What does A stand for? Do you remember? What are we looking for?
Future value.
Future value. A is what you're going to get when A is the amount of the loan, and it includes all of the interest. So remember, this is not like simple interest where you're only looking for the interest, then you have to add it back in. Compound interest formula adds the interest in, right? 1 plus I, so it's adding the interest in. Okay? What does P stand for?
Principal.
The principal. Okay, and that is your original or present value. Your starting value, right? How much you deposit or how much you borrow, because this could be a loan or an investment, works the same way. Okay? What is I? Interest as a what?
Decimal.
As a decimal. Good. But remember, what if you have more periods than annually? Do you remember what happens when you do that? We're going to have to convert it to a percentage per period. And so remember, we get that K. It's been a while since we looked at that, where it's kind of like the N you just did, but it's not N because N is compounding periods per year. K is compounding periods. So it's the thing you wanted to do earlier. So if you say monthly, for example, that would be 12 times the number of years, and that's your K. So if I had the loan for 5 years, that means 60 periods. All right. So I'm sorry. So you divide by, just divide by 12. We haven't got to the K. That's our K. All right. So we'll just divide. So I got a step ahead of myself. Divide I by K. And that'll give us our rate per period. Okay? Now, and then N is the number of compounding periods, right? But again, it's either years if it's just yearly, or it's N times K if you have another period. So this is what I was doing a second ago. Sorry about that. So, for example, guys, so if it was monthly for 5 years, that makes my N 60. Right? 12 times 5. Quarterly for 6 years makes it 4 times 6, so 24. It's the total number of periods.
What does K actually mean?
K is just the number of periods if it's less than 1 year. Now, actually, K, you have K even if it's 1 year, but if it's 1 year, K is 1. So if you divide by 1, you get the same thing you started with. So it's really even there even if you don't see it. Yes?
Wait, so if K is 5, do you divide I and multiply N by 5?
Yeah, right. You divide I by 5 to get the interest rate, and then you multiply N by 5 to get the
number.
It's the same multiplier, right? One divide, one multiply. Okay? So your interest rate is going to get smaller because you've got smaller pieces, right? But the number of compounded periods is going to get bigger because you have more of them. Okay? So let's just walk through the steps for making this work. First thing, list all variables. Now, you're not going to want to do this. You're going to want to just start plugging things right into the formula, but I'm going to tell you, you should list all of your variables. It will give you a kind of a heads up about what's happening. And you'll also see, for example, it may say compounded monthly. And you're like, well, where do I put that? Compounded monthly would mean you have a K of 12, right? So it'll trigger all the pieces that you need and remind you that sometimes you're going to have a little more math to do than others. Okay? 2, write down values of P and I. Everything is based on your principal amount. So make sure you focus on that, knowing which one is the principal amount. Because sometimes they're going to give you the amount of the loan. You need to make sure that you pay close attention to which one is the principal amount. Also, why do I say I? Because they're going to give you interest originally as a percent, and we need to convert it to a decimal, right? And we may also then need to divide it by 12 or 4 or 2 or some other period if it's compounded more frequently than once a year. Okay? So that's why we focus really heavily on those two pieces. Okay? Then, calculate N. Now, if you're only compounding annually, then N is simply the number of years. But if you compound monthly, etc., then we need to multiply. We'll have some multiplier, right? If it's monthly, you'll multiply your number of years times 12. If it's quarterly, you'll multiply a number of years times 4, etc. Okay? So those are just the little pieces that you really need to make sure you focus on. Step 4, substitute those values into the formula. Once you have all your pieces, then it's simply a matter of substitution, right? And the formula is pretty straightforward. Okay, so here you might want to look for a K, because that's what would change your I, if you have a K. All right, now, and then 5th step, really easy, solve. Now, you're solving an equation, so solve the equation. And remember, to solve an equation, you simply do the opposite, right? After you clean it up, but you're going to have some stuff to do in the brackets, so you're going to need to do that when? First, right off, right? Unless your variable is in the bracket, then you can't. So your variable can be any of those values. So if you think back at the formula, so let's just bounce back to the formula, I could be looking for A. That's the dream situation. That's the one you want to happen, because then it's just a matter of plugging numbers into your calculator. There's nothing to do. But I could also be looking for P or I. And in the worst case scenario for most of you, I could be looking for N, which is an exponent. And that's the hardest, well, not hardest, but that's the one that requires a little more work to find. Okay? So recognize that any of those things can be your unknown. So we need to go through some examples of each one so that you can see what the equation looks like. Now, you have 2 options here when you're working with this. You could plug in all the numbers, then solve the equation. Or you could say, well, I'm trying to solve for I. Let me rearrange the formula and make I the subject of the formula first, and then plug everything in, and then it's just a matter of using your calculator. Most of you are not going to want to rearrange that formula for every single problem. Instead, you just need to focus on solving the equation. But it really makes no difference which one you do. I know you've looked at rearranging formulas in the past and changing the subject. If you want to do that, that's fine. But you need to remember that some pieces of that as we go. So we'll look at that if you want to, but I'm just going to plug in the numbers and then solve the equation because I'm assuming that's what most of you will do. Let's take a little poll. So plugging it in and solving the equation is the one we'll focus on. Now I will warn you though that if your exponent, the n, is the unknown, there are two ways to do it. You can get an exact value by using logarithms, which is something that we looked at before briefly, but didn't come up on our test, but might this time. Or you can use guess and check. Just plug in numbers until you get a value that looks like what you want. And we'll look at examples of both of those. You get full credit for either one as long as you get the right answer. All right? Logarithms are much easier because your calculator does all the work, but you're just going to have to remember what to do. But we'll look at both of them. All right. So let's just go to the book and look at a few of these. So, solving problems involving compound interest, all we're looking for is the future value. The homework for this is all of them, so we're just going to bounce into the exercises and do a couple of them. So, just look at question 1. Use the compound interest rule to determine the balance for the following loans and investments after the given period of time. Round your answers to the nearest cent. Remember, we're talking about money here, so we're going to round it to the nearest cent. Okay, so we have, in this particular problem, $2,500 borrowed for 3 years with compound interest of 3.5% per annum, compounded yearly. So in this one, not very interesting, because if it's compounded yearly, will the interest rate change? No, so let's look at one where it does, just for kicks. Here we go. Look at D. We'll do 1D. All right. So we have it makes it bigger. So we have $26,000 invested for 60 months with a compound interest rate of 4.6 per annum, compounded monthly. So our A, which is our future amount, we don't know yet, right? That's what we're looking for. But we do know our principal, how much was invested? Well, we're doing D, so 26,000, right? Okay. Our interest rate was 4.6%, but it was compounded monthly, which means that we're going to have to multiply by 12, and first divide the I by 12 and then multiply our N. And the number of compounding periods, it was invested for 60 months, so no multiplying there. Why? Because they didn't give it in years, they went ahead and did the months for us. Okay? What if they had said 5 years? Then we'd have to do 5 times 12, which would give us the 60 months. This one, they were being nice to us. All right, so we have all of our pieces. Let's just flip over to some notebook paper so we can do the work. So our formula, A equals our principal, which is 26,000, times our 1 plus our interest as a decimal, but we have interest as a percent, and it's compounded monthly. So we need to turn it into a decimal, so 0.046, and then we need to divide that by 12. Okay? So that's going to give us a new I of 0.00383 repeating. Now again, you're going to do that in your calculator once you get everything set up. So let's just set it up first with what it would look like, and then you can put it in your calculator. So it's 0.046 divided by 12, because there are 12 monthly periods, and it's going to be raised to the 60th power because there's 60 months. So we didn't have to multiply that this time. Right? Now, when you're working on this, just like last time, remember you need to take it piece by piece and hit equals after every part. So, first, we would do this inside the bracket. So 1 plus 0.4046 divided by 12 is going to give you 0.00383 repeating. Okay? You don't have to write down every stage like I'm doing. I just want you to see where everything is coming from. All right? So, but you do need to hit enter after each piece to make sure your calculator is giving you the right values. Then to that value we'll add 1. So we get 26,000 times 1.00383, repeating, raised to the 60th power. Then we'll take care of that exponent. Remember, the exponent is always next. This multiplier out front is always last. So we'll do the exponent next. So 26,000 times, raising that to the 60th power. I don't have any idea. Anybody have that in your calculator? 1.25 what? 258. Okay. And then we just multiply that times our 26,000, which gives us 32709.21 dollars rounded to the nearest cent. Okay? So that one's pretty straightforward because we're looking for the A and the formula is actually solved for A. So it's just like plugging it into the calculator just like we did before. Be careful though and be sure to hit enter as you go. All right? Now, that's all well and good, except that they're not always going to be looking for A. So in your homework you have number 2A, and they tell you that at the end of the investment period, you now have $12,692.82. So that's the future amount at the end of the loan. Okay? How much would you have to invest to have it? So in other words, we don't know our principal amount. The interest rate is 6.9% quarterly. So in order to find my I need to first convert that to a decimal, 0.069, and then divide it. If it's quarterly, I'm going to divide it by what, guys? 4. Okay? Which gives me 0.01725. Okay? And then finally, I need my N, and we're going to leave it in there for 8 years. But is it compounded annually? Nope, compounded quarterly, so that means I need to multiply my 8 years by what? So that gives me 32 periods. So my N is 32. Okay? All right, plugging it into the formula. I know my A this time, so that goes over here. I don't know P, so it just stays P. So I don't know how much is invested. That's what I'm looking for this time. 1 plus my 0.01725 raised to the 32nd power. So if you go ahead and find your I and do that business, right, when you're looking at your I, it may make it one step easier. You don't have to. Now, I can simplify a little bit inside there. So 12,692.82 equals P. 1 plus that is just going to put a 1 there. Then I'm going to raise that to the 32nd power. What is 1.01725 raised to the 32nd power? Anybody? Pardon me? 1.9 point, what now again? 311? Oh, 391. Thank you. Okay. Now, I'm trying to get that P by itself. How is that number attached to the P? What operation? When they're side by side like that with brackets, what operation does that indicate? Multiplication. And what is the opposite of multiply? Yes? Divide, you betcha. So I'm simply going to divide both sides by that, and I should get P equals $8,500. So my original investment was $8,500. Okay? So again, fairly straightforward because we're looking for the P, and the P was outside of the bracket. Okay? Now, let's see what happens when we have a problem where we're looking for the amount of interest. So let's say that in the future, our loan value, or investment value, is $10,198.86. We originally invested $8,500. We don't know how much interest, but we do know that it was compounded quarterly. Okay? And it was there for 3 years, and of course, compounded quarterly means 4 quarters, so our N is 12. Does that make sense? Okay? So, we can do a little bit with this. I'm looking for I. I don't know what I is, but I do know I. In order to use it, I'm going to have to divide it by what? By 4. Okay. Now, plugging in that information into our formula is going to make it very interesting. So we're going to have $10,198.86 equals our principal, which is $8,500, times 1 plus I over 4 raised to the 12th power. Okay. Because it's your unknown, when you solve it, it's going to have the division by 4 built into the problem. Because your I is going to be that. So that's already there. So don't worry about dividing this one by 4. I'm sorry, guys. Just call it I. So if you have any unknowns, don't worry about dividing them by anything or multiplying them by anything. Just call them the letters. Okay? So sorry, guys. All right, here we go. Now, I have a bracket, but it's 1 plus I. Can you add a 1 and an I? No. Which means I also can't do the exponent. But this 8,500 is connected to that bracket by what operation? So I could move it, right? By simply dividing both sides by the 8,500. Okay. So what is 10,198.86 divided by 8,500 going to give us? $1.199865882 or something like that. Okay.
So it's $1 million.
Sorry?
It's $1 million.
So it's this thing divided by that should give us 1 point. Is that what you got? Okay. Equals 1 plus I raised to the 12th power. Now I've got to take that bracket apart. And the bracket is raised to a power. So I'm going to have to, what's the opposite of raising something to an exponent index? A root. Right? So what we'll do is take the 12th root of both sides. Oops, sorry. I didn't even mean to put it there. The 12th root of both sides. Now your calculator is fully capable of doing that. Any root of something. So you could take the 12th root of that. Right? Now, or use the reciprocal of the index. Do you remember that trick? If you don't want to take the root of both sides, instead of taking the square root of something, I could, instead of having it, so say like you have x squared. To undo a square, I would usually take the square root. But I could also use the index, the reciprocal, to turn that into a 1. What is the reciprocal of 2? 1/2. And what happens when you multiply 2 times 1/2? Turns it into a 1. In other words, it eliminates the exponent, right? Or the index. So you could take this thing and raise it to the, not 12th power, but what? 1 over 12? Okay? And now again, it doesn't matter which one you do. Most of you are probably going to say that you need to undo the exponent by taking a root, which is perfectly fine. But you also have that option. So if you remember that, you could also just change the exponent or multiply by the reciprocal of the exponent, which just means put 1 over it. All right? So when you do that, you get 1.0153 equals 1 plus I. Because over here, these two things are opposite, so they just eliminate each other. Over here, you're just taking the 12th root of that number, and that's what you get. Learn how to use your calculator with it. This will show up. Now, what's the only thing left to get my I by itself now? Subtract the 1. Exactly. So that gives me 0.0153 equals I. Okay, right. Now we want to change it to a percent. So that's 1.53%. But how many compounding periods did I have? Was it compounded yearly?
Not 12.
So, no, quarterly. So 4. So that means I need to multiply that number times 4. So remember, we still have to come back in because we used I. We didn't use our divide by 4 in our formula. We went ahead and just used it as I, which means we need to account for the compounding period because 1.53 is a very small number, very small percentage, isn't it? And when you do that, 6.12%. And there's your end. So be careful and watch that. We either have to account for that 4 in our original formula when we plugged it in, but that's really messy using I over 4. You could, but if you don't use I over 4 there, you're going to have to multiply it back in. So think about, would you remember to multiply it back in, or would you rather use I over 4 in your original problem? It's easier to multiply it back in, but you got to remember to do it. Okay? So that's why we need to pay really close attention to our I, always. That's why there's a whole line for it. Okay. One more example. What happens when n is our unknown? You have two choices. You can use logs, if you know it. It's really easy. I'm going to show you. Or you can use, you can use trial and error. Try n is 3. See if that works. Try n is 5. See if that works. But have you seen these numbers? What was n in the last one? 32. What was n in the first one? 60. Do you want to try to do this problem with a 3, and then try a 10, then try a 15, then try, etc., until you get to the right number? Because you're going to have to just do that over and over and over again. It would be much easier if you just learn how to use the logs, and the logs are dead easy because your calculator can do all the math for you. Okay? So I'm going to show it to you with logarithms, but you can do your own thing. Let's say we want our investment to be worth $5,000 or more at the end of the term. So how long would I have to leave my money in order to have at least $5,000? Is the question here. And we're going to invest $3,500. Our interest rate is 6.75% compounded annually. That's nice. Why? Yeah, just all I have to do is just change it to a decimal, and that's my interest rate. That's my I. Okay? How long would I have to leave the money in there? So I don't know how long I'd have to leave it in there. And that's why they're always going to do this. If they do this to you, they're always going to do it annually, because if they do it any other compounding period, it's a nightmare. So it's going to be just how many years, right? So that does make it a little easier. So it's not going to be 32 or 60 or something. But you still have no idea, okay? To turn $3,500 into $5,000, who knows how long that's going to take. Yes?
Say we were looking, say it was like quarterly or something. Does that mean in the equation we put like 4n? Does that mean you did?
Yep. You'd have 4n, which would be, it wouldn't be difficult, but it'd be a little more difficult than, they're not going to do that to you. But yes, that's exactly what they would do to you. All right, here we go. Let's plug it into our formula. 5,000 equals 3,500 times 1 plus 0.0675 raised to the nth power. Okay? Now, I can do something over here. What part of that has nothing to do with the nth power?
1 plus.
Oh, be careful. That's in the bracket, so it's raised to the nth power, isn't it? So the bracket is raised to the nth power. Which part has nothing to do with the nth power?
500.
The 3,500. So I can get it out of the way, and it will make your life easier. You don't have to technically, but it'll make your life a little easier if you do. So it's connected to that bracket with multiplication, so we'll take it apart using division. It'll divide away over there. Gives me 1 plus 0.0675 raised to the nth power. And 5,000 divided by 3,500 is 1.42857149. Can you tell I did this ahead of time? All right. You just leave it in your calculator. Okay. I can also do the stuff inside the bracket. And maybe that's what you were saying to do. Inside, I can add that 1 to that other number, right? I can add 1 to the decimal and turn it into one term. That'll make my life easier. Okay? But now I need to get rid of that exponent. And if you remember, the opposite of a variable as an exponent, because taking the nth root wouldn't do any good, would it? You'd have the nth root on the other side, and that's not going to help you. So what we need to do is we need to get rid of the exponent, and the opposite of an exponent, or the way to get rid of an exponent, is to use a logarithm. So all we're going to do is, step 1, take the log of both sides. Now, there's no math here. Your calculator is going to do all the math. You're just going to put log in front of this number and log in front of the 1.0675 raised to the nth power. That's what I mean by taking the log of both sides. There's no math involved there. You just put log in front of both of them. Second, move the exponent to the front of the log. Now, you don't need to know why. This is just a special thing that happens. It's one of those rules. It's just like being able to add exponents when you're multiplying. It's one of those rules. Anytime you have an exponent and you take the logarithm of it, it's the same as having that exponent become the coefficient or the multiplier. So that n is going to move up front, which means I don't have an exponent anymore. And that's the reason we take the logarithm. Okay? So if anything's weird that you're going to have to remember, that's the only part that's weird. But that's the reason why we can do this. Then, I need to get this n by itself. It's connected to multiplication, so I'm simply going to do division. So I'm going to divide both sides by the log of 1.0675. So divide. Okay? And from that point, your calculator can do this work. Right? But remember that you want to use brackets because I want the log of the top and then divide that by the log of the bottom. Shh. And you end up with 5.4604693373. If you take the log of the top divided by the log of the bottom, again, your calculator will do that for you. But I want this in years, so am I going to round down to 5? No. I've gone past 5 years, so that means I have to keep the money in there for what? 6 years. So if it's compounded annually, then you need your answer in years. And so we have to do 6 years. 5's not enough, right? So it has to be 6 years. Okay? Now again, once you get the keystrokes for the calculator and you do this a couple of times, it is dead easy. It's the easiest one of the equations we've solved so far. It just looks funny because you wrote log in there. Okay? If they're going to give you a really complicated problem, they'll give you one of these, which really, if you know the process, it's easy. Now, alternately, what I could have done is I could have gotten this simplified to here. Let me circle that in red so that you can see what I'm talking about. To here, right? Got it all simplified, and then plug numbers in there. Try 2, try 3, try 4, try 5, try 6, until you get that number to be more than 5,000. Now, some of you, the trial and error is just going to make more sense. You're going to just stick numbers in place of n and just give it a shot. But remember to simplify it first, and then do that. Don't try it up here and plug it in and do the math every time. That's going to take you forever. But simplify it as much as you can, and then just plug numbers in place of n until you get some number. But the math is harder, and you probably would not have guessed 6 originally. Most of you probably wouldn't have tried 5. You would have tried something smaller. But who knows? Okay? All right. So what we're going to do is we're going to look at a couple of these. We're going to look at some of those together. I'm going to give you your homework. Your homework is just to study the notes. Then next time we meet, we're going to look at some of these together. So study these notes, practice these, look at the examples that we've done so that you can understand what's going on. And then next time we meet, we're going to do some of these together.